Hello everyone, welcome to this presentation featuring Bizagi Digital Business Platform and how Bizagi enables your process applications to leverage the blockchain technology. My name is Daisuke Okuda and I will be illustrating the concepts regarding Bizagi's integration with blockchain and showing you a demo for the next 20 minutes or so. For those of you who perhaps have heard of blockchain but are not necessarily experts on the subject, or for those of you who are beginners with Bizagi, please do not worry. I will very quickly go over the essentials of both so that we can all easily get a good idea of this powerful capability. So the topics we will cover are: first, we will consider some definitions that best describe the blockchain technology. Then we will see a basic example in which from within a Bizagi application we invoke one service in blockchain. This includes a running demo, and we will have a look at how the demo was configured and talk about the feature in Bizagi that makes this easy. Finally, we will review some other potential uses with blockchain as a technology. Let's start by asking, what is blockchain? Well, on a high level, blockchain is a revolutionary technology designed to approach how two different parties, regardless of their location, can complete a trade in a secure manner. When we say secure, we imply many things, but a basic premise is that such trade can be trusted. Trusted in a sense that each party gets reassured that whichever asset is being exchanged is authentic. And authentic in terms of knowing that such transaction does involve the legitimate owner of that asset. We could then ask, what is revolutionary about it? An important objective of the model employed by blockchain is to eliminate risks entailed with data being held centrally, which basically suggests not having a central point of vulnerability that could eventually fail, be exploited by a hacker, or be arbitrarily manipulated. So if we now picture a payment as a transaction without a central entity to store and to attest its validity, such as a bank, then how can we tell the transaction is valid? The answer in simple words is that anyone could verify the transaction. Rather than having a central record-keeping system, identical records are spread across everyone connected to the network. They're all updated simultaneously, and transactions only go through when enough parties of the network sign them off. Overall, this part about any participant verifying or auditing a transaction is where the digital public ledger comes in, or also referred to as a shared ledger. Every successful transaction gets recorded in the ledger out in the open, while such transaction is written into a new block, chained chronologically to the previous block, and hence the term blockchain. There are, of course, security controls in place that involve timestamps, hashing, and private keys to look after this model's ability to prevent fraudulent transactions. I will not get into such in-depth subjects, for instance about how are these transactions validated, nor go into detail about the use of cryptography and digital signatures serving as a platform for security. But the bottom line about blockchain is that these blocks are afterward replicated across the network, rendering a database that is both distributed and decentralized. This network is also conceived as peer-to-peer, namely because it consists of nodes where they are all equally privileged. So in the end, blockchain's model is proving to be robust because once these blocks get verified and added to that chain, well, they become permanent and unalterable. Updating blocks is not allowed in this design, and given that there are multiple replicas under continuous use, well, tampering of information is pretty much prevented that way. Also, while relying on a public ledger, the model supports transparency due to the fact that anyone could trace historic transactions. Now let's move on to how, through Bizagi, you can empower modern technologies such as this one in an agile and easy way. First of all, and as a small introduction, Bizagi is a digital business platform which enables organizations to embrace digital transformations by typically having their process analysts build applications that fit the organization's need. So any structured or unstructured process modeled in Bizagi through standard notation known as BPMN can connect to any external service. In a nutshell, The role of the digital business platform is to bring together people and technology to optimize processes that in turn achieve efficiency in the organization. And all of this happens while supporting functional and non-functional requirements, such as being able to tackle business-to-business integration. So I imagine by now you all have your own examples of scenarios where processes are drivers that can end up orchestrating a series of events or a series of services, or in this case, leverage and automate the use of the blockchain ecosystem. For the demo, we will see one common and short process example. As briefly suggested in a previous slide, the trending and renowned applicability of the blockchain technology so far is centered around payments and the financial sector. Said payments being done in bitcoins. Now, bitcoins are a form of digital currency, and we could also say that such bitcoins have originated this recent wave that is fueling a closer look at how are blockchain concepts applicable in real life. We will use now an oversimplified example of a purchase request process whose workflow integrates services of blockchain.com to check for the balance in an account and eventually complete a payment. Now, technically speaking, accounts offered by blockchain.com services and as many other similar sites out there have actually wallets with rights to use bitcoins. Of course, these wallets have a unique and appropriate ID with access restricted by a password. So what we will see, and to sum this up, is having in Bizagi a connector that consumes the blockchain.com RESTful API to use a wallet where I have some bitcoins. This is a process outline for our demo. First, a requester submits a purchase order specifying what is it the user wants to buy. At this point, there will be a button in the user interface that fetches the balance from blockchain.com. Then an approver reviews this order. Assuming it gets authorized, the purchase is automatically triggered and completed at blockchain.com. So the two circled tasks are the integration points where Bizagi works with blockchain services. Without further ado, and for a less theoretical part, let's see it in runtime. So now I'm standing in a browser where the requester's name is Tom Hall and his username is Tom H, so I input it here along with its password and hit login. Now I am in Bizagi's work portal and Tom Hall here will request for a new purchase. This is Tom's relevant details and this is the form that needs to be filled out in order to submit a new request. Notice how I can select any of these products for purchase, and Bizagi also shows me its listed price. So I'm doing all of this because I desperately need a new pad for an optic mouse. Now, when I hit the check balance button, Bizagi will connect online to the blockchain wallet and fetch the balance. Here we go. I have 0.005 something bitcoins in my wallet's balance. So I'm going to switch over to that account at blockchain.com so that we can all double check that this fetch balance matches the ones the website shows me at this very moment. Here I can log into my wallet. And I can see the balance, which is 0.005 something bitcoins. Notice this is not a sandbox environment, this is a real account with my personal very small amount of bitcoins. So switching over back to Bizagi, and since I'm done with this request, I hit done. As shown on the screen, I can see that nothing more is expected from my side, and my colleague Martha Lewis will take it from here so that she can authorize the purchase. So I'm going to log out only to log in back again, but this time emulating it's Martha Lewis who enters Bizagi Work Portal to do her part of the process. Martha has an incoming new task. So Martha works on this task and Martha approves. Now, when I hit done, Bizagi will automatically finish the process, completing the payment as a last step. So before we do complete it, let me switch to yet another blockchain.com wallet over here. And this different one represents the target address who receives the payment for the pad of the optic mouse. As you can see, it has a current balance of 0.003 something bitcoins. So back in Bizagi work portal, I hit done to instruct the payment. While the payment is being verified, I'm switching back to blockchain.com and to the target wallet, where I should see that the balance has been changed automatically. So this balance corresponds to the one I had before, plus the mousepad price, which was transferred from the purchase. And switch over to the other wallet, where I should see it has discounted me the price of the mousepad plus the fee of the transaction involved from Bitcoin mining. So there I see new information as expected, and also I can see the transaction being recorded. Now, drilling down into how the integration with blockchain services was configured, this now means getting to see how the application was modeled here in the Bizagi Studio. I have that simple process example I defined. And here, for instance, where I have make purchase as an automatic task, I have instructed here to make the payment with blockchain. So if I click here, I can see how the invocation of the payment service is configured, all by means of a friendly wizard in 4 easy steps. So from the first step and from this list of connectors I have installed locally, I can see how it is already set to use the blockchain connector. And it's using the make payment method. So for the step number 2 has mappings for inputs. On the left hand, we have the data model of my specific process, and to the right, those parameters as expected by the blockchain service, such as the Bitcoin address and the amount of Bitcoins to transfer. Step number 3 is all about outputs, still under the same idea. This time, from left to right, we see what the service in particular returns to my data model. So in this particular example, I'm only interested in capturing the success message, and I'm storing in an attribute of my data model. Of course, when installing the connector, I also did put proper credentials to authenticate to blockchain and use that wallet of my choice. And that's pretty much it. Having looked at the configuration in Bizagi, here we can see the API that the connector is using, and for instance, that definition for the method that fetches a wallet's balance. So what the Bizagi connector is doing is relying on methods such as this one seamlessly. That said, installing ready-to-use connectors such as the ones available right now for blockchain or Ethereum is done by just downloading them from the connector's Xchange. The Bizagi Connectors Exchange is an online store with many free of charge connectors to plug and play directly into your own business applications. These connectors are one click away and are continuously being used, suggested, or even produced by the whole Bizagi community. This image shows the existing variety of some of the connectors available to the date in the Exchange, where we can see Ethereum, Azure websites, Amazon EC2 services, Twitter, Salesforce, or Moodle, to name a few. You may also extend or customize these connectors by using the Online Connectors editor to, say, add more methods to existing ones, or even create your own connectors. By now we have seen how you can empower processes in Bizagi to quickly adapt to emerging technologies and make the most out of their potential. And blockchain's potential relates to, for instance, what Ethereum is all about. Ethereum extends the blockchain model to virtually anything in particular that needs to deal with fraud or censorship issues, and not just covering Bitcoin's exchange. Of course, there is still digital currency involved, and there may be differences in the implementation of how Ethereum works when compared to Bitcoin implementations, but this is also not a subject for this presentation. So we are starting to hear about the further uses that the blockchain model has and how its huge potential is starting to stand out, with most resounding scenarios aimed at supply chain for the manufacturing sector or the general use of smart contracts. It is expected for supply chain processes to benefit greatly from this model because the history of an asset or its raw materials would be up for a transparent lookup. And regarding smart contracts, and this design promoted by Ethereum, let's clarify that as such, a smart contract can be understood as any contract capable of executing and enforcing itself. Contracts overall reflect how you can adapt the model to allow strangers to do business and simply trade anything of value, especially while reducing the time, costs, and constraints implied by having an intermediary. For the financial sector, although a distributed public ledger would seem to make redundant agents like credit card companies, for contracts this model would now be adapting to fields of action such as those relevant to a public notary office, where contracts undergoing this model enable people to even certificate marriages, having in this case the two parties exchange their agreement, if that's a way to say it. But there are for sure more use cases in sectors such as government, healthcare, music, film, and arts, plus some others we will see over the next few slides. Certain slight variations when it comes down to implementation details allow the blockchain model to target different use cases and create diverse applications. So variations such as now having private blockchains, in which the main difference when compared to public ones is that private blockchain implementations restrict the right so that not all nodes can write new transactions blocked to the chain. This approach still includes the notable benefits regarding a decentralized database and also oriented towards auditing. Another great applicability concerns social networks and how a reputation model can be built so that broadcasted information has real added value for users. And of course, there is how technology is always breaking up physical barriers, and this concerns now global trade, because transactions could be done far more easily, which translates to relatively very fast transactions achieved without the need of permissions in between. And this could be especially significant for developing markets or in communities where regular transfers are expensive and delayed, or maybe not as reliable. So let's take a quick look at some of the examples you could have in Bizagi. Here's a contract management process model outlining how at some point contracts are signed and executed between an issuer and an underwriter, which could mean here in this task of the workflow where you could integrate services based on the blockchain technology. Another one, and these are all taken from Bizagi's free templates at the process Xchange, it applies to the accounts payable as a final stage of a purchase order process. So we could envision a diverse payment being integrated with blockchain. Same goes for personal loans request, where it can be a major improvement for mortgage loans. This opens the door to being able to thoroughly analyze the ownership and the history of real estate or real property. In the sample process, it is done while in the step that verifies documentation for the credit. But that's just to illustrate how it could be easily included in a process model and to mention a few examples. So as we did see throughout the topics, applicability of the blockchain technology is moving at a fast pace, and Bizagi offers out-of-the-box features for your own process applications to easily leverage their services and seize its momentum. This is the end of the presentation. I hope you have enjoyed it, found key takeaways for your specific needs, and many thanks for watching.